Notice how well my wife is dressed as opposed to me. Yeah. Yeah. Okay, so I've got the slightly ambitious title of trying to think about how we can maintain ecosystems and livelihoods for the many people who rely on coral reefs for protein. And I'd just like to point out my co-authors at the bottom of the slide there. Okay, so the ability of reefs to recover and bounce back between bleaching events is going to be critical for their short to medium-term future while we try and get on top of these global-scale challenges such as reducing carbon emissions. And there's been a whole range of empirical studies and theoretical work suggesting that reducing local stresses to a reef, so chronic stress to a reef, is likely to promote recovery between these pulse disturbance events. And I think Luke Smith's talk this morning was a really nice example of that, and I should have borrowed some slides from him for the start of my talk, but that's basically what I'm talking about here. If you can reduce a lot of the other stresses, then the reef should be able to bounce back and the coral cover return. So this is some work we published earlier this year. And it was looking at two major threats to coral reef fish. So the x-axis represents what we call climate change vulnerability. What we're really talking about there is coral bleaching and habitat loss, so the death of coral and then the loss of that 3D structure, how that influences fish species. On the y-axis we've got fishing vulnerability, so how vulnerable different species are to fishing pressure, and that's based on various life history characteristics. Each of the bubbles, the dots on the plot, represents a different species of fish. And what you can see is that there's this really dramatic non-linear relationship where the species vulnerable to habitat change are not particularly vulnerable to fishing and vice versa. That's a problem because where you have both of these two stresses co-occurring, as you do on most coral reefs around the world, you're essentially removing different portions of the fish community and you're ending up with a smaller species pool at that given location. But there's actually a lot of good news in this figure as well, and that's because the identity of the species that are vulnerable to fishing tend to be the species, the functional groups that we believe are far more important in terms of ecological functions and processes. So the groups of fish such as roving grazers, scrapers, excavators that control algae and promote recovery, and also the macroinvertebrate feeders that control outbreaks of sea urchins and so on. So what that suggests is that managing this local stress, managing fishing, is going to be incredibly important for maintaining processes and functions on reef at a local scale when you're trying to tackle these global problems such as climate change and help reefs bounce back. There's a range of other studies, and I'm just going to show a couple of examples where local management, so reducing stresses at a local level, have had quite major impacts on processes. This is some work by Tim McClanahan in Kenya. We have age of marine protected areas along the x-axis, and then he's looked at the process of predation. So through these marine parks, through time in these marine parks in Kenya, you get a nice increase in an index of predation. And with that, you get a nice decline and a drop-off in the biomass of sea urchins. And sea urchins are a real problem in East African reefs because they cause a lot of bioerosion when they're allowed to outbreak into very high numbers. There's an excellent paper by Brian Stockwell, Gary Russ, Rennie Abesamis, and others in METS in 2009. And they looked at a whole range of different indicators, again, through time in marine protected areas, and they showed a nice increase in herbivore biomass through time in these protected areas, and with that, a decline in macroalgal cover. And this is just the correlation they showed between those two variables, where the herbivore biomass recovered in these protected areas, they had a large reduction in the macroalgae. So again, local management was having an impact on herbivory. And this is some work by Sean Wilson and a group of other people from the Seychelles. This is from data we've collected through time, and the last trip was earlier this year. And we've been looking at recovery of coral cover in the Seychelles since 1998. So the 98 bleaching event absolutely decimated the inner islands of the Seychelles. Coral cover was reduced to 3% on average. And since then, we've seen an average increase across all of these island groups of about 1% per year. But there's a huge amount of variation among sites. And what's really interesting is if you look at what's driving that variation in recovery rates, the two best predictors of recovery were whether macroalgae is expanding, so it's a dynamic measure of change in cover of macroalgae, and there's a negative relationship between macroalgae expansion and coral recovery. And secondly, MPA status. So in the absence of macroalgae, there's evidence of faster recovery rates within the marine protected area systems. So again, local management is having an effect on recovery. So what I want to do now, I'm talking about coast to coast, so I'm going to take you to a different coast, and that's across the Indian Ocean to East Africa. East Africa mainland and the reefs around the small island nations that are adjacent to East Africa. And this is a very different socio-economic context to the reefs around Australia. There's very high human population densities, there's high levels of poverty, there's a huge dependence on coral reefs for the resources that they can provide, and there's very few alternative livelihood options. In the region, there's roughly 30 million people that are directly reliant on coral reef fish protein. So in a region like this, reducing local stresses is incredibly difficult. And reducing fishing pressure is incredibly difficult. You can't put in large marine protected areas because these people rely on the fish for protein. So trying to reduce local stresses and combat big issues such as climate change on coral reefs in heavily dependent socio-ecological systems such as East Africa is a challenge. So we wanted to ask the very simple question of can thresholds be identified to guide management? So can you identify thresholds in the ecosystem which you can then feed back to managers to help manage the system? And by thresholds, we're talking about defined changes in the trend or the variance between a driver and various state variables. To do this, we really wanted to choose a driver that was measurable. It could be easily quantifiable, but most importantly, we wanted a driver that was tangible for management, something that managers could influence and could understand, and something that resource users could actually comprehend and influence through their behaviour. And for state variables, we wanted to look at a whole range of different indicators rather than just trying to choose one. So for the driver variable, we chose fishable biomass, so that's the fish above a certain body size and the species that are targeted in the region. And in that region, the fishing is multi-species and largely size-based. So the type of fish they go for is generally anything above about 10 centimetres. Now, we know that fish biomass is intimately linked to fishing, and that overfishing can have serious repercussions for the ecosystem. So we thought it would be a sensible, one of these chronic stresses to assess. And importantly, it's a very tangible metric that can be influenced by managers and by resource users. For the different state variables, we wanted to use a range that represented key ecological states and processes on reefs, so things such as predation and cover of algae and the competition between coral and algae and so on. So we compiled data from over 300 surveys of shallow coral reefs in the region. That was across 9 countries. And these were evenly distributed among unregulated, so open access, open fishery locations. Locations where there was restrictions on the kind of fishing, so the kind of gear that could be used or the mesh size of traps and nets. And also small-scale no-take marine protected areas in the region, and there's a large number of those. And then we used a suite of Bayesian switch point models to test for these trend or variance thresholds between the driver and the state variables. And we tested these switch point models against linear fits and null models. This is what we found. So you've got fishable biomass along the x-axis and your various variables along the y-axis. So the first changes we saw as you started removing fish, so you started going down this fishable biomass gradient, were 2 thresholds associated with macroalgae cover and the ratio between macroalgae and coral. Now these changes were associated with an increase in the variance. So you can see that below these threshold points, you suddenly get a lot more variance in the data. And that's because certain individual reefs have started flipping to macroalgal domination, whereas a lot of other reefs haven't. So it's not an on-off switch. You don't have everything flipping to macroalgae at that point, but that's the point at which you get lots of variation, and you start seeing reefs that are dominated by algae, and algae is outcompeting coral. The next threshold that we crossed was to do with predation. So there was a marked decrease in the predation rates below that threshold. So the ability of these organisms to control invertebrates. Then below about 300 kilograms per hectare, we saw quite a quick succession of changes. We saw a marked drop-off in species richness of the fish community. So if you start thinking about diversity stability ideas, we see a rapid decline in the number of species on the reef. We saw a reduction in the proportion of herbivorous fish in the community, and we saw a large increase in the biomass of urchins. So with that loss of predation, we saw an increase in the biomass of urchins, which is going to cause bioerosion on those reefs. And interestingly, the last 2 points that we saw these changes in trend were the percent cover of calcifying organisms and the percent cover of hard coral. Now that might be quite surprising, because many people will go out to a reef and assess its how healthy it is or what state it is by how much hard coral cover there is there. But we've heard time and time again, and we know from the story in the Caribbean from the 80s, that actually the hard coral cover isn't a particularly good indicator of the state of the reef. And once you lose hard coral cover, if you wait until that actually falls over, it's quite likely that you've lost all of those processes in the background that maintain the ability of the reef to bounce back between disturbances, and it's going to be very hard to return from that point. So how can we make this useful to managers? So we wanted to link it to a concept of multi-species maximum sustainable yield. Now, this is a concept that's being developed by largely temperate fisheries scientists who are working in temperate industrial fisheries. So Ray Hilborn, Boris Worm, and many other guys have started developing this extension of the maximum sustainable yield idea for a multi-species fishery. And they're suggesting that if you look at lightly fished and unfished reference points within your fishery area, that if you take the maximum that you see in those locations and you take 0.35 of that point, that's where you're likely to get multi-species maximum sustainable yield. Now, we were a bit concerned about this for applying that to a multi-species coral reef fishery where we have many more species and it's likely to be much more complex. So we took a very conservative window. We took 0.25 to 0.5 of these unfished and sort of asyntoping marine protected areas in the region, and we took this window of maximum biomass multi-species sustainable yield to be the area where we're likely to see this sustainable fishing yields. What that basically means is that if a location is being fished to that point, then the livelihoods, the long-term yields, should be able to be maintained. So you're unlikely to overfish the location. So that window is here, the grey area, and you can see the ecological threshold points that I showed you on the previous slide here. 3 of them fell above this hypothetical sustainable fishing window, and they can be considered warning points, and 5 of them fell in quite quick succession below it. If we then compare that to different management systems in the region, you can see that there's high variability among countries. If you take the average, you can see the general trends are that closed area management, so these small no-take marine protected areas in the region, are generally performing pretty well. They're keeping the biomass, the fishable biomass of the fish stocks above this sustainable window area, and in a lot of locations they're keeping the system above the majority of these thresholds that we identified. So in terms of the ecosystem, those no-take marine protected areas are performing the best. If you look at the areas with gear restrictions, so the orange bars, again, there's high variability, but on average, those locations where there's restrictions on the kinds of gear and the kinds of fishing that can take place are performing within this sustainable fishing window. So they're likely to be sustaining those fishery outcomes. Whereas the open access areas, again, high variability, but some of them are extremely low and they're generally falling below that window. So in conclusion, ecosystem processes and state variables can be influenced with local management, reducing local stresses such as overfishing, which is probably the pervasive one in the East Africa region, and linking indicators of ecosystem change with goals of sustainable fishing enables targets to be set for ecosystem-based fisheries management for managers to use and also for resource users to think about in terms of local management. There's quite a move for devolvement of ownership of resource user rights in the region to give much more power to local fishing groups to manage their own reefs. And such approaches should be useful to help managers sustain both ecosystems and the livelihoods that many people rely on. Thank you very much.